So our first speaker is Nicole Allgeier from Enerkite in Germany, and she will be presenting on behalf of Florian Breipol, who couldn't make it today. Please.
Yes, hello. As already said, I am representing Florian. He is our CEO, and I'm presenting for him the Enerwing. That is our wing. I'm, to be honest, not really into the wing topic, so I'm trying my best here. I will start with a short video to show what type of system we have, because not everyone might know us. Unique for us is the rotational start. As you can see here, we have a fixed kite who is docked at the mast system. The system rotates around the ground station. With that, we can basically get with almost zero wind at the ground into heights where always is wind. That's kind of unique in the airborne wind scene. Also, the rigid kite is kind of unique. I will tell you more about that later on. Here you can see the transition into the 8 flight. So we are also doing a yo-yo cycle here. What you can see here is our previous kite system. It was only there for testing. It's really cheap and easy to repair. But it was easy to for the software to learn with that kite because it has some advantages here. With our system, we are able to do the direct retraction because of our kite is able to be steerable. When we reach the top of the height, we can steer and then land directly. Maybe a quick sum up, where are we standing now? So we had the concept proof in 21, meaning we had the full operation from starting operation and landing, fully automated. That we did with the left system here. It's our long livable system. It's a truck, and we have mounted here the system on it, so we can test in different situations. We are currently building and mounting the prototype. The prototype is a combination of the top, so the actoric of the old system. The rotating parts will be placed on the new prototype ground station. It is capable in theory, like batteries and everything, they are capable to do 100 kilowatts, but we will start with smaller wings and smaller mast systems, so we are scaling in steps to avoid any difficulties by scaling too fast. Also we have had some difficulties, non-technical, why we are a bit behind in schedule, but we're still planning to fly with the new system this year. Next year, then we will scale up with new kites to 100 kilowatt. Series product, meaning the pre-series systems will be then be hopefully developed until 27. Yes, as already said, I'm now here for the wing. The wing is patented. It's a fully integral grid shell monocoque design, meaning as you can see here, we have a full design. Maybe to get a better understanding. Sorry, maybe I will skip that first, sorry. Maybe to get a better understanding, we have compared different types of construction. What you can see on the left is a conventional construction. We have many parts. You are mounting them together. You have spares and ribs. It takes a long time to mount it. It's also not very helpful if anything happens. If you try to replace something, you really have to take some time to replace it. We built that actually. We had a project, also called Enerwing, where we built both of the systems in a small scale version. Yes, and so we know the advantages and disadvantages of both, but as you can see, the main disadvantage obviously is the the huge amount of parts, with over 1,000 parts here. Now, as I said, patented is the grid shell construction, it only has about 24 parts. They can be mechanically mounted. It's highly durable. It's extremely lightweight. What you can see here in the video is no. What you can see here in the video is a video of the flight test. Unfortunately, only rotational start and landing. Hopefully surely next ABEC we will show you the full cycle with this kite as well. What you can see here now is a wing with 6 meters bandwidth. It has about 3 square meters. And it's extremely lightweight. So this wing, with everything like covering and electronics, weighs 12 kilogram. In long term, we are aiming for the weight of 2 kilograms per square meter of only the structure. So there will be some additional weight through the covering or maybe sensors and stuff, but the carbon fiber, they allow us to be really lightweight. Basically we can say that we have a system who is really lightweight, durable. It is durable against and robust. It is able to be robust under certain weather conditions, also able to be robust against birds. Maybe we will see what happens with birds. And so we are really proud to finally present it. I will give you also a short introduction, since we now have our production hall in Eberswalde, that is close to Berlin in Brandenburg. We have what you can see in the upper picture on the left. We have also still a contact office in Tegel at the airport, which is quite nice. The main parts are happening in the production hall. As you can see here on the pictures, we also have our own wind tunnel, and we are able to produce the first kites ourselves. Yes. So what you can see here, we have our own cutting machine, CNC cutting machine, where we are cutting the carbon fiber patches, as you can see in the picture below. Currently we are cutting off overlapping CFK parts ourselves, but in the long term it's super easy to do that with robots. Also, due to the low amount of parts, it's super easy to achieve a really easy mounting and production system. What you can see on the right is the implementation of resin on the vacuum. Yes. So, maybe also last slide here, perspective, where we want to get. So in general, for the whole system, we say we are comparable to land machines. So they have the similar or even more amount of parts. And we just done a research on how long and how much is needed to produce such systems. And we say that we can really compare to that. And also what is really nice, we have for the serious production, we have now some really big partners, and mainly for the wing, it's we are really happy to have Airbus on our side, who is doing with the ASTI production. And on a first evaluation, they assumed that we can have 120,000 operational hours with one kite. Of course, we have the ability to replace parts who are under more environmental aspects. Yes, but that would mean we are having a durability of 10 to 15 years with one system. Until then, afterwards we have to replace it. Yes, and that basically is it. I tried to replace Florian, but any questions I will be happy to forward to him then.
Thank you. a very advanced system there, so congratulations. I have one quick question up front. Sure. When you showed the system, but now we cannot see it anymore. Yes, that one. Sorry.
Yeah.
So the mast and all this rotating equipment looks very massive.
Yeah.
Compared to the little container and the platform. And considering that this rotates, it's hard to imagine that does not fall over. Is this to scale or?
I did not draw it, but I think it should be to scale, but maybe we will, or I think we will have a small foundation.
Okay.
So depending on the ground.
Thank you.
Yes, but in general, we are aiming for a 30 feet container, so also mountable on truck and easily installed, and yeah.
Thanks. Any other question? Yes, here, Rod. Wait a second.
Wow, well done. That's incredible.
Thank you.
That slide there, it mentions a low, a mid, and a high wind speed. Is that
Yeah.
the wing?
Yeah, that is then done by the wing. So we are currently, what you saw and what we are aiming for first is 10 meters per second design wind speed. But in long term, which would be then of course a high wind speed. But in long term, we will be able to, or we try to do 8 meters per second design and something in between. I
So
think.
are you intending that 3 wings are deployed to a site for when the wind changes? or is
No,
it,
no. So, but if we are looking at the wind speeds all over globally, we will provide the wing matching to the
Okay.
site. Then, like
you.
for example, Bavaria in Germany will have something else than, Brandenburg in Germany probably.
Thank you. Maybe one more question. Yes.
But
Hello. Yeah. Very good presentation. So my name is Ignacio Cruz from CIEMAT. So I have a question about the manufacturing process. So I think that the new strategy for manufacturing is
Yeah.
based on 24 pieces, parts.
yeah,
And my question, I think that you are, it has been used in
that's slide.
yeah, the infusion, vacuum infusion solution. But it seems that there's half of the wind, more or less. So what are the main difficulties just to manufacture the wind, one-shot wind? So just one.
That
like
is probably a question I have to pass over because I'm not in the wing production at all involved. I'm really sorry. But I will come to you afterwards and then note it down and send you the answer. Okay?
Thank you very much.
Perfect.
Thank you again, Nicole.
Okay.